So this unit is all about radicals. We're going to learn how to add and subtract them, multiply, divide, simplify. We're going to start with just simplifying radicals. So the first thing we want to make sure we all agree on is the vocabulary. This check mark kind of thing right there is called a radical symbol. Whatever number is here is our index. Whatever is underneath is our radicand. And then the whole thing is called a radical. If the index is not written, so if it's blank, it is automatically a 2 or a square root. When we simplify radicals, a radical expression is in simplest form if the radicand contains no perfect square, cube, etc. Factors other than 1, and the variables have an exponent less than the index. So if we come down here, if I have the square root of 25, well, that one's nice, so that's just going to be 5. The square root of 2,940 is going to be slightly bigger. So remember that we might need to make a list. So square root of 25 is nice, but we could always make a list of our perfect squares. When we do that, we figure out that 196 is a perfect square, and it divides into 2,940. And that will be multiplied by 15. The square root of 196 is 14, and the square root of 15. The other way that you can do it, you could also make your factor tree. So you would factor tree out and then circle your pairs and they come outside, and whatever's not circled stays inside. For 3, we've got the square root of 72, x cubed, y to the 4th, z to the 5th. When you do it with the radicals, you're going to divide the exponents by the index. So we know that this index is 2. So square root of 72, square root of 36 times the square root of 2. X cubed is, to be able to divide by 2, the closest thing is squared. We can't go over the 3. And then we can divide 4 by 2, so we keep that. 5 can't be evenly divided by 2. We can't go over 5, so that's going to be z to the 4th and the square root of z. You're going to go through and do each of those square roots. Square root of 36 is 6. Square root of x squared is x. Square root of y squared, or y to the 4th, is y squared. And then the square root of z to the 4th is z squared. And then you go through and you put everything you couldn't do inside its own square root. So 2xz. So for 4, we have the cube root of 48, x cubed, y to the 6th, z squared. So when we do this one, we can make a list of perfect cubes. So we just do 1 cubed is 1, 2 cubed is 8, etc. And you're going to find the biggest one that can divide evenly into 48. In this case, it will be 8. And 6 times 8. X cubed, 3 can be divided by 3, so we're going to keep that the same. Y to the 6, 6 can divide by 3, so we'll keep that the same. And then z squared, 2 can't be divided by 3, but there's nothing smaller than 2 that can be divided by 3, so we're going to keep that the same as well. Cube root of 8 is 2. Cube root of x cubed is x. 3 divided by 3 is 1. Cube root of y to the 6, 6 divided by 3 is 2. And then we can't do the other stuff, so we get the cube root of 6z squared. And then for the 6th row, 64, x to the 6th, y to the 7th, z to the 13th. The 64, we can make our list of perfect 6. So 1 to the 6 is 1. 2 to the 6 is 2 to the 6 is 64. So that comes out nicely. So we can just do the 6th root of 64, which is 2. I can do the 6th root of x to the 6th. The 6th root of y to the 7th is going to be y 6, because we can't divide 7 by 6. And 6th root of y. And then the 13th is going to be the 6th root of y, or z, sorry, 12. And then the 6th root of z. I can divide 12 by 6. I can't divide 13 by 6, though. I'm going to go through and do each of those. So we said that the 6th root of 64 is 2. 6 divided by 6 is 1. So x to the first. 6 divided by 6 is 1. So y cannot do 6, the 6th root of y. 6th root of z to the 12th. 12 divided by 6 is 2. And I can't do the 6th root of just z. So we got the 6th root of y z. What do you notice happens with the variables? So you just divide the variables by the exponent, or by the index. So divide the exponent by the index. I want you to now pause the video and try 6 through 11 on your own and check your answers on Schoology. Once you have done that, come back. Welcome back. The next thing we're going to talk about is multiplying radicals. When we multiply radicals, you multiply the radicands and then simplify. You could also simplify first and then multiply. You multiply inside by inside and outside by outside. So for number 1, we've got the square root of 5 times the square root of 35. That's going to become the square root of 175. When you do your perfect squares, you're going to find that it's the square root of 25 and square root of 7, which gives you 5 square roots of 7. When you have 3 square roots of 7 times 4 square roots of 8, you're going to do outside times outside. So that 3 times 4 is 12. And then inside times inside, 7 times 8 is 56. And then you're going to take that 56 and see if you can break it up at all. It's going to break into the square root of 4, square root of 14. So we got 12 times 2 square roots of 14. So we're going to get 24 square roots of 14. For 3, again, we can do outside times outside. So 3 times 1 is 3. And then inside times inside. 4 times 28 is 112. And we're going to have x to the 5th. Remember, when you multiply with exponents, you add the exponents. We're going to have to simplify that. So we're going to get 3 square root of 16, square root of 7, square root of x4, square root of x. 3 times 4, x squared, square root of 7x. 12x squared, square root of 7x. For 4, we got outside times outside, so 4 times 5 is 20. Inside times inside, 2 times 6 is 12. X times x is x squared, y squared. The 12 can be broken into the square root of 4, square root of 3, X squared and y squared can both be square rooted. So we're going to have 20 times 2 x y squared of 3. So we're going to get 40xy squared roots of 3. And then for 5, outside times outside, that gives us -2. Cube root, 2 times 6 is 30. 2 times 16 is 32. We're going to have x to the 7th y cubed. So -2, cube root of 8, cube root of 4, cube root x6, because 3 cannot go into 7, but can go into 6, and then we'll have 1 left over, so cube root of x, and then cube root of y cubed. So we'll have -2 times 2. We can't do cube root of 4, cube root of x to the 6. 6 divided by 3 is 2, so x squared. Can't do cube root of x. Cube root of y cubed is just y. And we have the cube root of 4x. We'll have -4x squared y, cube root of 4x. I would like you guys to try 6 through 8 and check it on the key on Schoology. Then you are finished the notes for today. Please make sure you do the required assignment on Schoology and then the mini concept check for today.